Okay, more special angles. As a reminder, this information here you need to be able to either have memorized or produce quickly on the test because it won't be given to you. So you need to quickly know that the 45-degree triangle has these values 1, 1, square root 2, and the 60-30 triangle goes 1 to root 3. Okay, so we're going to state the exact trig value for these functions. Tan of 45. Well, first off, I'm just going to confirm that I know where tan of 45 is. And so I know that tan of 45 is in quadrant 1. This is relevant because I need to be able to figure out whether or not these values are positive or negative. So in quadrant 1, tan of 45 is going to be positive. Then I'm going to use my special triangle to go, oh, well, tan is y over x, or opposite over adjacent. So the value of tan 45 is just 1 over 1. Okay, tan of 330. So I know that tan of 330 is in quadrant 4, or in here, and so I know that it's in quadrant 4, and I want to know what the RAA is. So in quadrant 4, I'm just going to go 360, take away 330. I know that's going to be 30, so my RAA is 30. Now that I know that, I'm going to be looking at my 30 degrees here, and I'm going to just state the tan value. So that's opposite over adjacent. So that's 1 over root 3. This time though, because I am in quadrant 4, and that's this quadrant here, my tan value is not positive, so I have to put a negative sign in there. Okay, now I get to add fractions with unlike denominators that are actually also rational numbers. So in order to add fractions, I have to have the same denominators. I have to have like denominators. My denominator that I'm going to use is root 3. So I'm going to multiply this first term by root 3 on the top and root 3 on the bottom. That's going to give me root 3 over root 3 plus negative 1 over root 3. All right, now that I have like denominators, I can combine those things. So I'm going to have root 3 minus 1 over root 3. The next step we're going to do is called rationalizing the denominator. So let's write that there. We don't want to have rational numbers in the denominator. We want to make sure that we've got whole numbers. Okay, so we want to turn this into a whole number. So the easiest way to do this is to multiply, find the equivalent ratio by multiplying this whole thing by root 3. So I'm going to multiply this by root 3, this by root 3, and the bottom by root 3. Okay, root 3 times root 3 is just going to be 3. Negative 1 times root 3 is going to be root 3. And root 3 times root 3 is 3. Now this answer is done. This is the exact trig value for this function. All right, let's try another one. All right. Sine of 225. Well, I know that sine of 225 is greater than 180, but I'm just not sure how much. So I'm going to go 225 minus 180. Oh, that tells me it is 45. And so I'm going to just draw that in here. So this is a 45, and it is in quadrant 3. Okay, and I want to keep track of that information because it's super relevant. So RAA of 45. So I'm going to go back to my 45 triangle, and I'm going to find the sine value for this. So I've got opposite over hypotenuse. So I've got 1 over root 2. And then I need to decide whether or not it's positive or negative. It is in the third quadrant, so sine is negative in this quadrant. All right, next I've got cos of 135. Well, 135 is less than 80, So I'm just going to make sure that cos of 135, that's actually this guy right here. Okay, so that's also a 45 degree. So this is in quadrant 2. My RAA is 45. So I'm going to go back to my 45 degree triangle, and I'm going to get my adjacent over hypotenuse. So that is 1 over root 2, because I'm using adjacent over hypotenuse. And then I need to decide that I've got a positive or a negative angle here. And I'm up here, I'm in the sine quadrant, so this also has to be negative. Okay, last I've got to do cos of 360. Well, cos of 360 is, there's no RAA. That's just right here on the line. Okay, now I'm going to remember that cos is x over r. And I do have an x value. I have an x value of 1. So this is 1 over 1. All right. Now that I have this step done, I'm now ready to combine my fractions using like denominators. So first step, I'm going to make sure that everything has a like denominator. So I'm going to multiply this guy by root 2. So I'm going to have negative 1 over root 2 plus negative 1 over root 2 plus root 2 over root 2. Negative 1 plus negative 1 is negative 2 plus root 2 over root 2. Sorry. Now I notice that in this case, I actually have a common factor. Oh, sorry, I don't have a common factor. I have to rationalize the denominator. All right, so I'm going to multiply this whole thing by root 2. So negative 2 times root 2 is negative 2 root 2. Root 2 times root 2, 2. Root 2 times root 2, 2. Now I have a common factor. I notice that all of these things can be divided by 2. So I'm going to do that. I'm going to factor out. So I'm putting this into lowest terms now. So I'm going to factor out this negative, this 2. So in the end, I'm going to have negative root 2 plus 1. And then that'll cancel because that would become a 1 on the bottom.